Good day, everyone. Thank you again for joining. And we are now going to move on to our paper 3. Let's get ready with your paper 3. Okay, this is the question, and I hope that you have already completed. Now, this question is talking about what? It is talking about two sets of experiment carried out by a group of students. Keywords of the question, compare elasticity between natural rubber R and vulcanized rubber S. This is the aim of experiment. I repeat, when we are doing paper 3, always refer to the aim of the experiment. And the weight which is being hung is 200 grams on each rubber strip. Next, what is being measured? The length of the strip before the weight is hung and after the weights are removed are measured. Okay, now let's look at the diagram, see whether you have problem to understand it or not. Now see the picture, they are showing you this is a rubber strip, okay, natural rubber strip before the weight is hung. This is the size. For R, you are going to just clip it with the weight of 200 grams. And you will see that the R becomes longer. Can you compare? Did you see? I hope you see. And for S, actually, what is happening for set 2? Oh, this is actually the same rubber strip from the natural rubber, which is labeled as S. But this time, it is being immersed into the sulfur monoxide solution. This sulfur monoxide solution is actually going to change this natural rubber to become a vulcanized rubber. Okay. Now, how to form vulcanized rubber? The sulfur cross-link is introduced between the rubber chain. Okay, so you please refer back to a textbook for the diagram of the structure. Now, continue. After you have turned it to become the vulcanized rubber by immersing it into the sulfur monoxide solution, the same thing here, hanging the 200 gram of weight, and next you are going to measure the length after the weight is removed. Did you see the length is the same? Okay. Now, again, which is more elastic from the diagram here? Why I am asking you about which is more elastic? This is because the aim of the experiment is to compare the elasticity of natural rubber R and vulcanized rubber S. So, which is more elastic? It is vulcanized rubber S is more elastic than natural rubber R. Now, let's move on. In the diagram, they are showing you a ruler. Okay, remember, when you want to record the data or record the reading, which is measured by a ruler, how many decimal place? Remind you, it is 1 decimal place. Okay. Now, what is the initial length? Before you measure, before you record, I want you to take note about this. Sometimes the question does not start from 0. Now, this question is very good. They don't trap you. This is 0. So, straight away, you can take the initial length here. Sometimes it will start from 1. Then you have to minus. So, you please check your answer. For the question, measure the length of all the rubber strips and record the reading in the space provided. You please check your answer. For part 1, set 1, you should have 10.0 centimeter. Can you see there is no unit given to you? So you should put your answer as 10.0 centimeter. Okay. Now, for the R, this part for the S, what is the initial length for the S? Here, initial length for the S, it is still 10.0 centimeter. If you don't put centimeter, it is wrong. Okay, next part. Now, we are going to move on to the next one here. For this one, after the weight is removed, it becomes how many? I hope you can see. And you should be getting your answer as 11.0 centimeter. And for the S, the answer is still 10.0 centimeter. please remember to put the 0.0. Okay, next part. Now, part B. Construct a table to record the length of all rubber strips before the weight is hung and after the weight is removed, and extension for rubber strips for set 1 and set 2. So now, what is the keyword here? Number 1, you should know that you will have set 1 and set 2. Okay? Then you will have the length before the weight is hung. Column number 2. Column number 3, the weight, the length after the weight is removed. And column number 4, the extension. All this must be put in the unit of centimeter. So what are you going to do will be, you can have a table. Now I'm going to put your answer here. You can have a table. This is your table. Okay. Next, you are going to put the line. Okay. Now you are going to have your title as set. You will have set 1. Then you will have set 2. Column 2, column 3, and column 4. Okay, now for the first column here, you are going to put length of rubber strip before the weight is hung. Use the unit as centimeter. This one, this is the title here. Okay. Now please note that you must have your unit as centimeter. Unit as centimeter. Okay. Now for this column, for this one, this part here, what are you going to write? You are going to write the same thing from the question here. The length of rubber strip when the weight is removed. Just copy directly. Don't forget about the centimeter. And the last column here, copy this extension of rubber strips. So again, the unit as centimeter. Just copy back the value that you get just now from up there. Now for set 1, the extension will be 1.0 centimeter. And for set 2, the extension will be 0.0 centimeter. Don't put only 0, it is 0.0 centimeter. Okay, so next part. Okay, we are now going to the next part. State one observation that can be obtained from this experiment. Can I hear from our friend? One of you who can tell me your answer? What is your observation? Can we hear from this Wan Yin?
The length of natural rubber extends after weight is removed, while the length of vulcanized rubber has no difference.
Okay, I think you want to express about this. The length of natural rubber extended after the weight is removed, while the length of the vulcanized rubber does not change after the weight is removed. Okay, you can also write about the extension where you have already calculated just now. Okay, can follow? That is observation. Observation is what you get from the diagram, from what you observe. Of course, the best answer will be you tell the natural rubber is extended, the length of the natural rubber is extended after the weight is removed, but the length of the vulcanized rubber does not change after the weight is removed. That is the best answer because you can see it from the diagram. But if you want to talk about the 1.0 centimeter and 0.0 centimeter, that one is not wrong. Okay, next one. Based on the observation, state the related inference for this experiment. So what are you going to write about the inference? Okay, when you want to write about the inference, you go back to the aim of the experiment. Can I hear from our friend Valencia? What is your answer?
Teacher, because natural rubber R does not have sulfur atom in between, but rubber S is vulcanized rubber.
Okay, I have a question, everyone. After listening to Valencia's answer, you check back, relate to the aim. Did she answer related to the aim? Where you are asked to compare the elasticity between the natural rubber S and vulcanized rubber, natural rubber R and vulcanized rubber S. Did she? Valencia, did you? Did you answer about the elasticity?
No, teacher.
No, right? Therefore, your answer is not accurate. Okay? I cannot say that you are wrong, but then your answer is not accurate. Your answer will be used for paper 2, but not paper 3. Okay? So your answer here, you should be putting the vulcanized rubber S is more elastic than natural rubber R. That is the best answer. Okay, next part. What is the MV here? Should we hear from Yijun? MV? Okay, the type of rubber. Everyone, I hope you can accept. And what is the responding variable, Yeshen?
Elasticity of rubber strips.
Correct. The elasticity of rubber strips. What is the constant variable, Kachun?
The
What
mass
is
of load.
the?
Mass of load.
Okay, the mass of load. In the question, did they use the word load? In the question up there, did they use the word load?
No.
No, right? So what is the word that they use?
Wait.
Huh? They are using the
Wait.
word weight. So you should change your word to weight. No using the load, huh? Okay, now we continue with our next question. We are now talking about the hypothesis. State one hypothesis for this experiment. Should we hear from our friend? Who is our friend to answer? Ridwan, can you answer? What is the hypothesis?
Vulcanized rubber is more
Cannot hear you, baby.
vulcanized rubber is more elastic than natural rubber.
Cannot hear you. Not clear. You can type for us. And Adrian, can you please help our friend? Adrian?
Teacher, he said vulcanized rubber is more elastic than natural rubber.
Oh, our friend said vulcanized rubber is more elastic than natural rubber. Yes, exactly.
Yes, teacher.
Correct. Okay, very good. Now we continue. State the operational definition for the elasticity of rubber in this experiment. Now, before we can state the operational definition, I want to know which rubber strip is more elastic. Everyone knows that it is the vulcanized rubber S, right? So now, why do you say that this vulcanized rubber S is more elastic from our observation? Why do you say so? Can I hear from our friend? Who else I have not called today? Dylan. Dylan, why do you say that it is S to be more elastic?
Because it's vulcanized.
Oh, because it's vulcanized. Are you sure? How do you know that it is more elastic or less elastic in our question here? Satya?
From the extension.
From the, yes, from the?
Extension.
Correct, from the extension. So which one will extend more? The natural rubber, right? So when it extends more, that means it is less elastic. Okay, now when we are answering operational definition, we have to answer two questions. Question number one, what do you do? Question number two, what do you observe? So what do you do first to test for the elasticity? Someone give me your sentence, please. What do you do to test for the elasticity, Dakshish?
Hang the weight on the rubber strip.
Okay, how much is the weight?
200 gram.
200 gram. Okay, so what you do is a 200 gram weight is hung at the natural rubber strip and the vulcanized rubber strip. That is what you do. Okay, now what do you observe? I would like to ask our friend Amisha, what do you observe?
The extension of the vulcanized rubber remains unchanged while when a natural rubber strip is used, the extension of strips become longer.
Okay, so can you make your sentence shorter? Actually, I think she wants to express about this. The natural rubber extends more, but the vulcanized rubber does not change or does not extend at all, or the length of the vulcanized rubber does not change. Okay, now I repeat, what you observe is the length of the natural rubber increases or the natural rubber extends after the weight is removed, but the vulcanized rubber, the length of the vulcanized rubber does not change after the weight is removed. I hope you can follow. I repeat, what you do is, you don't have to write your answer, what you do there. The terms, what you do, you don't have to write. You just say a 200 gram weight is hung at the natural rubber and the vulcanized rubber of the same initial length. What do you observe is, when the weight is removed, the length of the natural rubber extends, while the length of the vulcanized rubber does not change. Okay, so this is about your operational definition. Now, next part. If this experiment is continued by adding the mass of the weight, the rubber strip will break. Now, which one will break first? Adeline, which one will break first?
Natural rubber.
Good, you get 1 mark. Natural rubber will break first. Okay, now explain your answer. Why it will break first? Can we hear from Yanjun why it will break? Again, I give yes. Why it will break first? Refer to the aim of the experiment. Our aim is to compare the elasticity. So why does it break?
Not stronger.
Which is not stronger? Is the word strong mentioned in the aim?
The natural rubber.
Natural rubber what? Are you going to use the word strong or elastic?
Elastic.
Yes, therefore your answer, the natural rubber is less elastic compared to the vulcanized rubber. I repeat, whenever you want to answer related to the inference, to the hypothesis, or to explain, you are going to refer actually to your aim of experiment. Okay, now next part. The natural rubber is stretched by adding weights and extension of rubber strip within 5 days are recorded. Day 1 to day 5. You see the length, the extension is getting longer and longer. Now, based on the table, state the relationship between the number of days and extension of the rubber. And this time, I would like to hear from Avi. Avi, can you tell us your answer?
Teacher, when the number of the days increases, the extension of rubber strip also increases.
Okay, good. See ya. In your question, did you see that this number of days comes first? The extension of rubber comes last. So in your answer, this one also should come first. So you are just going to add in the word as. As the number of days increases, the extension of rubber increases. That's all. Okay, not difficult at all. Now we continue. Describe why vulcanized rubber strip can return to its original length after the weight is removed. So what are you going to tell? In this case, you are going to tell something that relate to your paper 2, like what Valencia said just now. Okay. Now, what do you have in your vulcanized rubber strip? Just now, Valencia said it is having a cross link, which is made up of sulfur atoms. And therefore, this is the part which makes it to be more elastic. Okay. And when there is this sulfur linkage, it causes the rubber molecule to be having less possibility to slip over each other, and therefore it won't become loose so easily. Okay, now your answer should be this. Please check whether you have this point. I'm going to write for you. Okay, this is your answer. Have to add in the cross-link present between the rubber molecule chain. This part here, add in. Okay, now it is formed through strong covalent bonds, and this reduces the ability of the rubber molecule chains from sliding over one another easily. You can add in easily. Okay, now we cannot prevent it from sliding. We are going to only reduce it. If you prevent it, meaning it will not extend at all. It will at last if you hang a weight to it for a very long time, it is still going to be extended. Okay, so this is about our explanation. Please know about this explanation, important. Okay, now next part. We are now going to move on to our next question, which is part J. Given to you are some solutions, and you are now going to classify into substance that can coagulate latex and substance that does not coagulate latex. I repeat, when you are doing this type of question, you are going to have your table. Must have your table. Okay, let's say this is the table for your classification. You are going to put your title left and right, or you can put your title top and bottom. Is okay. Okay, now let's say you want to put your title top, left and right. So this sentence, the substance that can coagulate latex, this sentence, substance that can coagulate latex, you are going to put it here. Okay, substance that do not, I will put it in a red. This one, substance that does not coagulate latex, the one in red, you are going to put it here. Okay, this title copy exactly here, this one copy exactly here. Okay, now what are the substances that will coagulate latex? Can you please tell me, Yijun? Which one will coagulate latex? Sorry?
Acid.
Yes, all the acid, which is number 1, number 2, and number 3. All these will coagulate latex. Okay? The sodium hydroxide, the ammonia, and the potassium hydroxide does not coagulate latex. Okay? So this is our first part of the paper 3. Now, our second part of the paper 3. The conversation shows an experiment. Can you see? To determine the heat of neutralization between acid and alkali. Now, Y reacts with sodium hydroxide solution, and another one acts to react with sodium hydroxide solution. Meaning to say, what is the manipulated variable here in this case? It is the type of acid, okay? And the teacher is asking, what is the temperature reading? Should be thermometer reading, or the temperature change and the value of heat of neutralization obtained. So in this case, they are actually determining the thermometer reading and also the heat of neutralization. And they found that both of the temperature increased, but I got lower temperature and lower value of heat of neutralization than Adit. Then they are asking, why are they having this problem? Okay, that is because of what? The important part here is different, the readings are different because using different type of acid. So in this case, they are actually talking about how different type of acid affect the heat of neutralization. Okay, now from here, can you see naming? That means you have to state one name for acid X and one name for acid Y. Then you determine the heat of neutralization. Okay, now acid X and Y. What can be X? What can be Y? Now, the X should be a strong acid. The Y should be a weak acid. Therefore, you are going to name any strong acid for X and any weak acid for Y. For example, the X should be the hydrochloric acid and the Y can be the ethanoic acid. Now, the statement of problem. Check your answer. Does the hydrochloric acid and the ethanoic acid affect the value of heat of neutralization when they react with sodium hydroxide solution? Or you can say, does the acid X produce a higher heat of neutralization when react with sodium hydroxide solution compared to acid Y to react with sodium hydroxide solution? Please remember to put a question mark behind of the question, behind of the sentence. Now, all the variables, the MV will be the type of acid, or you can put hydrochloric acid and ethanoic acid, or you can put acid X and acid Y. The RV should be the heat of neutralization. The constant variable will be the volume and concentration of sodium hydroxide solution. Please put volume and concentration. Okay. Now, list of apparatus and substances. Check. First, you should have your these materials first. You can have your hydrochloric acid, ethanoic acid, and sodium hydroxide solution. Please don't forget to put in the concentration. And for the apparatus, you should have thermometer, polystyrene cup with its lid, and also measuring cylinder. Okay, now next part, the procedure of the experiment. What are you doing for the procedure? I go fast because we have already mentioned this many times. So for the procedure number 1, measure and pour 50 centimeter cube of 1 mole per decimeter cube of hydrochloric acid into a polystyrene cup. Record its initial temperature. Next, we are going to talk about this sodium hydroxide solution. Again, use the same volume and concentration. Measure and pour 50 centimeter cube, 1.0 mole per decimeter cube of sodium hydroxide solution into another polystyrene cup. Measure and record its initial temperature, or the initial temperature of the sodium hydroxide solution. Now you have already have 4 steps. Step 5, add the hydrochloric acid into the sodium hydroxide solution quickly. Must have the word quickly. Next, cover the polystyrene cup with its lid and stir the mixture using the thermometer continuously. I repeat, cover the polystyrene cup with its lid and stir the mixture using the thermometer continuously. Next, record the highest reading or the highest temperature achieved, or record the highest temperature reached. The last step, you are going to repeat the steps. Check your procedure, how many steps you have, by using the ethanoic acid to replace the hydrochloric acid. Okay, I hope you are okay with the procedure. And the last part, we are going to talk about the tabulation of data. So for the tabulation of data, you can have your table like this. This is your table, let's say. Okay, now you are going to have here this part. You are going to separate it from more. Okay, here, this part, you are going to write the reaction between sodium hydroxide solution with hydrochloric acid. The reaction between the sodium hydroxide solution with ethanoic acid. This one and this one. Okay, next. Down here, 1, 2, 3, 4, you are going to put the initial temperature of the acid, initial temperature of the sodium hydroxide solution. Then you are talking about the average temperature, the highest temperature, and last one, you will have to have another one row, which is the temperature change. Okay, I repeat now. This part, you are going to write about the reaction. This one, you put in words, please. Okay, this one will be the initial temperature. Please don't forget to put your unit as degrees Celsius. This is the first column. Then the same thing, initial temperature of NaOH, degrees Celsius. Then this part, because you have 2 solutions, so you are going to have your average initial temperature, degrees Celsius. Next part here, you will have your highest temperature. Degree Celsius, and the last one, temperature change, degree Celsius. And you are going to leave this part blank. Okay? Any problem? Any
Sure.
problem? Yes.
Sir, I use hydrochloric acid and sulfuric acid. Can?
Hydrochloric acid, is it a strong acid?
Yeah.
Sulfuric acid, is it a strong acid?
Yeah, both is strong.
Then what's the difference?
Because
So,
the number of
is it
hydrogen
correct?
ions different. No.
In this case, we are talking about the strong and the strong and the weak, and the weak and the weak. Okay? So if you are using HCl and NaOH, it is the strong and the strong. If you are using the H2SO4 and the NaOH, it is also the strong and the strong. Therefore, this is not the good one, not the correct one. You should choose one strong and one weak. Okay? Any problem? Any more until here? No more? Okay, if no more, then I'm going to tell you what should you do for our next lesson. Okay, now for our next lesson, I want you to do for the Pahang paper, the set 2, objective question 1 to 10, and the structure 1 and 2. Sorry, objective 1 to 10, structure 1, 2, 3. I repeat, objective 1 to 10, structure 1, 2, 3. Okay, so this will be discussed on next Monday. Okay, if you have no problem, this is the end of our lesson, and I'll see you in our next lesson. Thank you. Bye and
Thank you.
stay safe. Okay, bye.